Hello students, so we were solving exercise 4.2. So I'll solve question 9 today. Okay, so here the question is given this a determinant you have to prove equal to this. Okay, so let's start solving it. So we have to do some row operations or column operations. Okay, now we want here x minus y, y minus z and z minus x. If we look at the elements here, if I take this y minus x, okay, so I'll get x minus y, right? And z minus x, I'll get z minus x. So operating on R2, that is R2 minus R1, and on R3, that is R3 minus R1. Okay, you will get LHS x square yz. Okay, this will be y minus x, this is z minus x, this is y square minus x square. So applying formula a square minus b square, you will get y minus x, y plus x. Okay, for this also z minus x, z plus x. Here zx minus yz, so you can take out z, so it will be x minus y inside, and here it will be xy minus yz, so you can take y common, so x minus z. Okay, now we are removing, that is we are taking out x minus y from R2 and z minus x from R3. So x minus y from R2 and z minus x from R3. So inside you will get x, this will be minus 1, this is 1, x square, this will be y, y plus x, that is minus y plus x, and z plus x. Here it is x minus y we are taking out, so z and y. Okay, so next we want we got x minus y and y minus z minus x. Now we want y minus z, right? So here we have the terms here, right? Y minus z. So you can take R3 this we are removing z minus x, so this will be minus. So you can take here we want y minus z, right? So R3 we can change it to R3 plus R2, so you'll get z minus y. Okay, so 1 minus 1 0, z plus x minus y minus x, and this will be R3, so z minus y. Here also we are getting z minus y, so taking out y minus z from R3, you will get x minus 1 x square minus y plus x yz z. So here it is 0, you are taking out y minus z, so this will be minus 1, again this will be minus 1. Now we want this xy plus yz plus zx. So I'll expand this determinant along R3. Okay, let's see what we get. So this is plus minus plus, plus minus plus. So 0 is 0, minus of minus 1, so 1. Crossing out this to row and column, so we'll get xz plus yz, then minus 1 x minus xy minus x square plus x square. Okay, so this gets cancelled, so you'll get this is your xz plus yz and minus into minus plus xy. Okay, next question is question 10. Okay, first one. So this is the determinant given and we have to prove it to be equal to this. Okay, so if you look at the elements, you will notice that if I add this column elements, you will get 5x plus 4, right? So adding all three rows, okay, R1 changing to R1 plus R2 plus R3, you will get here x plus 4 plus 2x plus 2x, that is 4x plus 1, 5x plus 4. You will get the same thing in this second column also and third column also. Okay, now we can take out this element common, that is from R1, 5x plus 4. Okay, now we want 4 minus x square, right? So want it in the form of x square. So 4 minus x square means we want to take out common 4 minus x and 4 minus x. 4 minus x the whole square it is, correct? Yeah, 4 minus x into 4 minus x. So we have here x plus 4. So we have to change it to 4 minus x. So if I take this x plus 4 minus 2x, what I will get? 4 minus x, right? Again here it will be 0, 2x minus 2x. Then for this term you will get again 4 minus x, correct? So operating along C2, okay, so C2 minus C1, and operating along C3, C3 minus C1. So let's see what we get. C1 remains same, 1 minus 1 0, 1 minus 1 0, x plus 4 minus 2x, so it will be 4 minus x, then 2x minus 2x 0, 2x minus 2x 0, x plus 4 minus 2x 4 minus x. Okay, so now here this first row in these two elements are 0 and 1 is 1, so you can expand along R1. So let's see what we get expanding along R1. So it will be 1, 4 minus x into 4 minus x. that is 4 minus x square, x the whole square. Okay, let's solve the second sub question. Okay, we have to prove it equal to k square 3y plus k. Again, if we add along this, okay, then you will get here 3y plus k, right? So first step is clear, that is r1 we are changing to r1 plus r2 plus r3. So this will be 3y plus k. Again, this is also same and this is also same. Okay, now we are taking out common 3y plus k. Okay, now we want k square. So you have to operate either on R or on C. Okay, let's operate on column. Let's see what we get. So if I take the same steps like C2 changing to C2 minus C1 and C3 changing to C3 minus C1. So I'll get 3y plus k so 1 minus 1 0, 1 minus 1 0, y plus k minus y, we will get k, then y minus y 0, y minus y 0, y plus k minus y is k. So expanding along R1, we'll get k square. So we got the answer k square 3y plus k. Okay.